Up to now, we've concentrated mainly on examples like a die roll or a coin flip to explain the basic concepts of probability. In this lesson, we're going to look at another type of example that occurs very often in real-life situations. So here's an example of this type of situation that we're thinking about. So suppose that we have a bag containing 3 green balls and 5 red balls. What's the probability of selecting a green ball if we select one randomly from the bag? So this is an example of a problem about a random selection from a population. So the population here is the balls in the bag. So in probability and statistics, populations have a more general meaning than groups of people. Here the population is the collection of balls, and we're selecting one randomly from the bag, and we want to know the probability of getting a green one. We can apply all our knowledge about equally likely outcomes to this situation, as long as we write down the sample space properly. So let's say what the sample space is first. So remember that in general the sample space is the collection of all possible outcomes of a trial. So what are the possible outcomes here? Well, it's tempting to say that the possible outcomes are green or red, but that won't help us much because those are not equally likely outcomes. Instead, what we really need to do is think of each of the 8 balls as a possible outcome. So we can imagine numbering the balls 1 to 8. There are 8 in total in the bag. And then the possible outcomes are each of the 8 balls, and these are equally likely outcomes. So let's say that balls numbered 1, 2 and 3 are green, and that balls numbered 4, 5, 6, 7 and 8 are red. So there are 3 green balls and 5 red balls. So now you can see that the sample space consists of 8 equally likely outcomes. Now, what's the probability of selecting a green ball? Well, remember, when the outcomes are equally likely, the probability of an event is the number of outcomes in that event. So how many outcomes here correspond to a green ball? Well, 3 of them, divided by the total number of outcomes. And the total number of outcomes here is 8. So the probability of selecting a green ball is 3 over 8. And while we're at it, we could easily write down the probability of selecting a red ball. In that case, how many outcomes correspond to the event of selecting a red ball? Well, 5 of them. And the total number of outcomes is 8. So here's another example. In this question, we are looking at the results of a maths test in a particular class. Our hypothetical student here, John, has collected data from his class on the grades of the last maths test, and he wants to work out what's the probability that a randomly selected student from this class achieved a grade of C or better. So in the table here we see all the grades listed in one column, and in the right hand column we see the number of students that achieved that grade. Okay, so how do we solve this? So first of all, we want to think about what is the sample space here. What are the possible outcomes? Well, the trial that we're doing here is selecting a random student. So the possible outcomes are all the students in the class. So it's important to realize here the outcomes are not the grade of the student. The individual outcomes correspond to the students that are in the class. So how many students do we have? The total number of outcomes is 5 plus 7 plus 12 plus 11 plus 3 plus 1. That must be the total number of students in the class, right? Because these numbers tell us the numbers of students that achieved each grade. So the total number of students in the class is the sum of all the numbers in the right hand column. And when we add that up, we get 39. Now, to calculate the probability that we are looking for, we need to know the number of outcomes that correspond to the desired event. So how many of these outcomes correspond to the student having achieved a grade of C or better? we look and we see that there are 12 plus 7 plus 5 students who achieved a C or better. So the number of outcomes in the event in which we're interested in is 5 plus 7 plus 12, which is 24. So the probability of a randomly selected student achieving C or better, I'll abbreviate that to C or better, is 24 over 39. And we can cancel a 3 there and get 8 over 13.